This is section 10.6, conic sections and polar coordinates. So we're continuing with conic sections, but this time we're using polar coordinates instead of Cartesian coordinates. So once again, there'll be 4 cases, and these are what the equations are either going to look like. They're going to look like this one, this one, this one, or this one, depending on which direction the parabola or the ellipse opens, or the hyperbola. So the way you determine which of the 3 it's going to be is by the eccentricity. That tells you whether it is an ellipse, if it's less than 1, if it's a parabola, if it's equal to 1, or a hyperbola, if it's greater than 1. So let's take a look at the first example. Write a polar equation of a conic with the focus at the origin and the given data. So notice that they all have a focus at the origin, all of these. All right, so it tells us that it's a parabola, and it also tells us that the directrix is x equals -3. Since it's a parabola, automatically we know that the eccentricity has to equal to 1 because it's a parabola. All right, and because the directrix is x equals -3, we can eliminate these two, and that means that it has to be this one or this one. Because it's negative, that means it's going to be this case. So that means our equation must look like that. So it's going to be of the form r equals ED over 1 minus E cosine theta. Well, we already know that E is 1, so we can substitute 1 for E. And also the directrix, as you can see up here, is equal to -D. So our directrix, which is -3, must equal -D. And that's because it tells you here x equals -D. So x equals -D. So therefore D must be positive 3. So now we have our D, we have our E, and that's all we need to complete the equation. So substituting that will give us r equals 3 over 1 minus cosine theta. That does it for problem number 1. All right, let's move on to the second one. So this one has a few parts to it, 4 parts. Find the eccentricity E, identify the conic, give the equation of the directrix, and then sketch the conic. So let's first identify which of the 4 types it's going to be. This tells us right here, the plus sign theta will tell us that it has to be this one. It's the only one that has a plus sign theta. So we know it's going to look like this. So let's copy the equation down. All right, or let's just sketch it for now. So it's going to look, parabola is going to open down. Okay, that's 1 plus E sine theta. So we need to make this a 1. The way you make this a 1 is by factoring out a 2. So if you have that, you can turn that into 1 plus 1/2 sine theta. So I factored out the 2 from the denominator in order to make that a 1, because that's what we need. And now we know what our E is. Our E is 1/2. And you can move this 2 to be up in the numerator by just writing this as 1/2 over 1 plus 1/2 sine theta. So now we know our E has to be 1/2 because E is this number. All right, and we also know that ED has to equal 1/2 because the numerator is 1/2. All right, so if we substitute 1/2 in for E, we're going to get 1/2 times D equals 1/2, which means that D equals 1. So we have D, we have E. All right, and now we can identify the eccentricity, or find the eccentricity, which we've already done. E is equal to 1/2. B, we can identify the conic. Because E is 1/2, and that is less than 1, that means we have an ellipse. And the notes tell you that here. If E is less than 1, then it's an ellipse. All right, and then part C wants to know the equation of the directrix. Well, going back, the equation of the directrix for this one is y equals d. So d is 1, so y equals 1 is our directrix. And lastly, we need to sketch. So if you sketch, you can just draw the coordinate plane. Okay, the directrix is 1. I'll do that in the dashed line. The focus is the origin. So our parabola is going to look something like this. I'm sorry, it's an ellipse. It's going to look something like this. It's just a sketch, so it doesn't have to be like super perfect. All right. All right. So now we need to find the vertices in order just to label these 2 points, and that's all we need in terms of just to get a more accurate sketch. So in order to find these 2 points, these vertices, we're going to substitute the angle because this is polar. This is a polar coordinate plane. So we can plug in. This is right at angle pi over 2. This is pi over 2. All right. So and this is 3/2 pi. So if you plug in pi over 2 into the equation, we can plug it into the original equation, pi over 2. We're going to get r equals 1 over 2 plus sine of pi over 2. Sine of pi over 2 is 1, so this is going to be 1/3. So 1/3 when the angle is pi over 2. So that would be the top vertex, this one. So vertice would be 1/3, comma, pi over 2. The other vertex is down here, which is at angle 3/2 pi. So let's plug in 3/2 pi. 1 over 2 plus sine of 3/2 pi. Well, we know that sine of 3/2 pi is -1. So this is going to be 1 over 2 minus 1, which is 1. Right? Yes. And so that should do it. So that's going to be our other vertex, which is going to be 1, comma, 3/2 pi. Which makes sense because, well, this is not drawn to scale. So at the angle 3/2 pi, this would be distance 1 away. So it's not drawn to scale, but these are the correct vertices. All right, so I'll just write vertices next to them. All right, let's move on to the next problem, which has the same directions as the previous problem that we just did. So first thing we should do is factor out the 2 in order to make this a 1. So if we do that, we're going to get 5 over 2 parentheses 1 minus 2 cosine theta. Let's write the 2 in the numerator. So that's going to be 5 over 2, 1 minus 2 cosine theta. Automatically, we know that our E is 2 because this is E here. So so let's start with that. Eccentricity is equal to 2. Part B, since E is 2, which is greater than 1, that makes it a hyperbola. All right, we can confirm that here. If E is greater than 1, it's a hyperbola. All right, part C, now we got to determine what the equation of the directrix is. So E times D has to equal the numerator, which is 5 over 2. Plugging in 2 in for E will give us, solving for D will give us 5/4. So if you look at the format of this equation, that's minus cos. So go back here. Minus cos would be this one, minus cos. And so the directrix is x equals -d. X equals -d for the directrix. So therefore, in our case, it's going to be x equals -5/4. So that is the answer to the equation of the directrix. And finally, the sketch. And remember, this is a hyperbola. So we got to draw this and make it look like a hyperbola. All right, so let's graph the directrix first. 1, 1, 2, 3. So the directrix is x equals 5/4, which is 1 1/4, which is about right here somewhere. That's our directrix. Okay, what else do we know? Okay, we also know that it's a hyperbola, and so a hyperbola is going to look like this. All right, so we need to find the vertices in order to graph this more accurately. So we got to plug in pi and also 0. All right, so let's plug in pi and 0 because the two vertices are going to be on the x-axis. And so 0 is in this direction and pi is in that direction. So that's how we know which angle to plug in. So let's start with angle 0. So if you plug in 0 into the original equation, you're going to get, for theta, r equals 5/2 minus 4 cosine 0. Cosine of 0 is 1. So that's going to be 5/2 minus 4, which is negative 5/2. All right, so for the angle 0, we get negative 5/2. All right, now let's plug in pi. All right, my pen is acting up. Let me try this again. We know that cosine of pi is negative 1, so this would be 5/2 plus 4, since cosine pi is negative 1, so that's going to be 5/6. So that means that the other vertex will be at 5/6, comma pi. So let's graph those two vertices. So at angle 0, it's going to go to negative 2.5. So angle 0 would be this way, but negative 2.5 means you have to go in the opposite direction. So negative 2.5 would be right there. That's one vertice, which is going to go this direction. And then the other one is in the pi direction, we're going 5/6. So 5/6 would be slightly less than 1, so about right there. And so there is your hyperbola. Remember, it's just a sketch, so it doesn't have to be perfect. All right, so for part D, the vertices are negative 5/2, comma 0, and 5/6, comma pi. And that is it for this section.